Now, learning, we've seen some basics previously. Learning is a process of converting experience into expertise or knowledge. That's a very interesting statement. Okay, converting experience into expertise or knowledge. Forms of learning: any component of an agent. Remember, I said this before. I'm going to talk more about the word agent than rather human beings. So, any component of an agent can be improved by learning from data. Straight and simple. And we'll see how it happens. So, the improvements and the techniques used to make them learn, the agents, depends upon perhaps 4 major factors. For instance, which component is to be improved? Do we have any prior knowledge that the agent already has? Remember the word prior knowledge, previously something that you know about. So, which component you want to improve? What prior knowledge the agent already has on that? The representation used for the data, very interesting and important. The representation. And finally, what feedback is available to learn from. Feedback tells you you're trying to go somewhere and you take a step in that direction. Now, your sensors, your eyes, hands, feet, whatever else, that tells you, send you a signal that you are looking for a step to go down. You haven't found it. So, you don't found it, you're not stepping down. Your feedback mechanism that is happening automatically 24/7 basis, that tells you that you're wrong, you haven't found what you're looking for. Okay. So, that is very important. That is really the decisive factor in terms of the action that we take and the results that we get. The components to learn. The components of these intelligent agents can include, let's say, a direct mapping from the conditions of the current state to actions to be performed. This can be improved, for instance. Okay. Number 2, a means to infer relevant properties of the world from the percept sequence. Here's another word, percept sequence. A percept is the input that an intelligent agent is perceiving at any given time. It's happening 24/7 basis. Okay, it's an input that the intelligent agent is perceiving or receiving at any given time. Now, that input is added to the sequence. We call it percept sequence, which is like a complete history of each percept ever detected, ever seen so far in terms of that intelligent agent. Now, the action of the intelligent agent depends on the percept sequence, like history of that particular input up to that particular point in time. So, whatever time is now, whatever has happened in the past, that forms your percept sequence or the history. And the action that the intelligent agent will take will depend on all the historical factors as of now, up until now. Number 3, the information about the way the world evolves and about the results of possible actions that the agent can take. Okay, information about the world, how the world evolves, it changes, updates, and about the results of possible actions that the agent can take. So, the agent needs to know, if I take this action, this is what's going to happen. If I take this action, this is how it's going to happen. Number 4, the utility information. This indicates the desirability of the world states or the environment, meaning the utility, the action that is performing, how important, how useful does the environment perceives that result, the utility information. We'll see that in a while. Number 5 are action value information, indicating the desirability of the action. Now, until now, what we've discussed, the action that you take and how good or bad are those actions. Remember that discussion we had on chess game, for instance. So, you take an action and indicate the desirability of that action. How good is that action, okay, compared to another one that I can take. So, you need to have that information, action value. Goals. Now, goals describe classes of states whose achievement maximizes the agent's utility. Same thing as I said in chess. So each of these components can be learned, can be improved. So consider, for example, an agent who's being trained to become a taxi driver. So if you see on the diagram, this taxi driver is in the middle, and it is, let's say, a number of cars or obstacles or objects around itself, and each with a particular distance. So one is at 25 centimeters, the other one is 30, 25, and so forth, as shown. Now, what exactly we are training the agent for, given that scenario, is trying to become a good taxi driver. Every time the driving instructor shouts brake, right, the agent learns a condition and action rule, when to brake. Okay, so conditions are given. The driving instructor shouts brake, so it stops, it takes an action to stop the vehicle. That's one of the components. The agent also learns every time the instructor does not shout, by seeing many camera images that the agent is told has buses in it, and it can learn to recognize them as well. That's component number 2. So it is being trained, it has been told that there are buses, and begins to recognize them based on the instructions. So by trying actions and observing the results, for instance, braking very hard on a wet road, it can learn the effects of its actions. We all know, we've heard, we've seen, maybe experienced what happens when you brake very hard on a wet surface. You're likely to skid and lose control. So that is the action as well, component number 3. Then eventually, when it does not receive a good tip from the passengers who have been thoroughly shaken up during the trip, because the driver took maybe too many hard brakes and it lost control. So at the end of the journey, there's going to be no tip. So it can learn a useful components from its overall utility function. That's component number 4. Okay, so these are some of those things that we're trying to teach our agents. Okay, how to recognize, how to move about, how to make decisions, and how to improve upon them. Okay, the 6 values that we have covered. So very short, but I hope you found it interesting and challenging. We'll see you next time. Thank you very much.